In this problem, we're taking a look at Katy Perry concert with varying ticket prices. They are actually the ticket prices I found when this event took place back in 2011, and we're told that the ticket prices are 42, 50.2, and 60.6, and then we're told how many people can be seated in the different categories of price ranges. We're to construct a row matrix P with the varying ticket prices. So we know a row matrix is a single row, and there are 3 ticket prices, so it's got to be a 1 row by 3 column matrix. Here it is in my calculator. Now I'm going to create the 3 by 1, which I have actually already done, and this one is a column matrix, and it's going to consist of the maximum possible number of people in attendance for each of the 3 seating zones. So 3,000, 1,500, and 500. Next, we're to find P times N. Well, before we do this, before we just grab out our calculator, we kind of want to think about what this represents because we're going to need to interpret it. So our P matrix is the row matrix that has 42, 50.2, and 60.6. And the column matrix is the one that's going to have 3,000, 1,500, and 500. So what's going to happen is this guy is going to collapse down and it's going to multiply these values. So what are we getting here? Well, the rows here represent the different high, we'll call them low, medium, high price, low, medium, high, and it's multiplying by the low, medium, and high prices. So 300 times 42 tells me the number of maximum revenue that's going to be generated by selling all 300 tickets at the high price. Oh, excuse me, we have this, I think we have this as 300, it's supposed to be 3,000. So 3,000 times 42 plus 50.2 times 1,500, that's the total for the medium range seats, and then 500 times 60.6 is the total revenue for the high price ticket. So we'll do this, we're not going to do this by hand, we'll just enter it in. So we want to make sure that we're taking the 1 by 3 by the 3 by 1, and just to see what we expect, our inner dimensions are the same. That means that we're going to end up with a matrix that is 1 by 1. So it's going to have a single total value price in there. So we're going to do second matrix A and second matrix B, and we get this is equal to $231,600 of total revenue. Does it make sense to find N times P? Well, let's try it. So if we flip these two matrices, 3,000, 1,500, 500, and we have a 3 by 1 times a 1 by 3. So that's what this would be. N is a 3 by 1, P is a 1 by 3. So technically we could still do it, and we'd end up with a 3 by 3 matrix. Well, what kind of 3 by 3 matrix would this be? Well, let's see what happens when we do this. We take a 3 by 1 times a 1 by 3, and we get a very strange looking matrix of values. So there's all kinds of things going on here. Well, let's see what's actually taking place. So we have 3,000, 1,500, 500, and then we have 42, 50.2, 60.6. Now each of these is a column, so this column is going to come crashing down. It's going to collapse down all of these guys here, and it's going to multiply them. So I'm taking $42, the ticket price for the low-end seats, times the number of low-end seats, and then I'm going to drop that to the next place, but now I'm taking a ticket price for low-end seats and I'm multiplying it by the number of mid-range seats. That doesn't even make sense. This number has to do with the ticket prices that are over here. So we're kind of mixing and matching here, and by the time it drops all the way down to the bottom, 500 times 42, well, now you're taking the number of high-end seats and multiplying it by the price for a low-end ticket. So the units don't even match up. So this is dollars per low-end ticket, but this is the number of low-end tickets. But then once you get here, you take dollars per low-end times the number of medium tickets. Well, now what do you get? Medium tickets times dollars over the number of low tickets, not a unit that we can actually work with. So this just doesn't make sense. Now it says change P into a column matrix and N into a row matrix, then multiply Pn. What do you notice? What I'm going to do in my calculator is I'm going to do a little trick here. So since I want to convert this into a column matrix, there's a feature called transpose. And so let me just show you what that looks like. So there's A, and all I want to do is invert it. All I want to do is invert it so it's not a 1 by 3, but instead a 3 by 1. So what I can do is I can actually come over here and second matrix to math, and I'm going to do this little T button here, this little T here, which looks like an exponent. What that stands for is transpose. So it's going to basically invert the matrix so that now it's a column matrix. So what I'm being asked to do is to take P times n when I've inverted both of them. So my P matrix is my price matrix. That's that's this guy here, and I want that matrix transposed. So I'm going to just transpose it, but I'm not going to hit enter yet. I'm going to multiply that by the second matrix, the n matrix, that contains the number of tickets, also transposed. So I'm going to come back into matrix, and so basically I'm symbolically rotating them. So now I have a 3 by 1 by a 1 by 3. Well, what am I going to get? Well, there's that bizarre matrix again. I got it the same way, just by rotating this guy and making it vertical, and rotating this guy and making it horizontal. So again, that does not make sense. That's just another way to obtain the same bizarre matrix that we got before, or mixing and matching values and ticket prices, and it doesn't make sense.